Hello, in today's video we're going to be discussing section 7.5 on properties of logarithms. We're going to be talking about what we call expanding logs and also condensing logs using some of the properties associated with logarithms. So first I'd like to discuss some basic properties of logs, and the first is here, log with a base of b of 1 is going to equal 0. And the reason that is if I have a 1 here, then the exponent on my base of b will need to be a 0. A base to the power of 0 is going to equal 1. So this is always going to be true for any non-zero b. Log base b of b is always going to equal 1. And the reason that is if I have a b and I raise it to some power and end with a b, so b raised to some power is going to equal b, well that b has to be raised to the first power. So therefore my exponent here will be a 1. Thirdly, I have b, and when I raise it to a power, I get b to the power of x. So if I have b and I'm going to put some exponent here and I get b to the power of x, well then that exponent that I'm raising b to must also be x in order to get b to the power of x. And lastly, I have a base of b raised to a log in the exponent of base b of x, and this is going to simplify down to just x. So essentially b to the power of log base b, you can think of those as inverses, leaving us with just x, so long as x is a positive number. And lastly, if I have two logs with the same base, so here I've got log base b on the left and the right hand side, and we know that they are equal, then that means the inside of the logs, the m and the m, must be equal to one another. So for example, if I've got log base 5 of 10, and that's equal to log base 5 of x, well, since we have log base 5 on both sides of the equation, then my x must be equal to 10. We're going to use that property to go ahead and solve the equation in example 7.5.1. So go ahead and pause the video now and try that out on your own. Since I have log base 3 on both sides, I know that 3x must equal 2x plus 5, and solving, I find that x is going to be equal to 5. Our product rule. Our product rule says if we are multiplying two things inside of our log, then we can split up into two separate logs by adding the two together. So for example, if I've got log base 3 of 5x, this is 5 times x. What I can do is rewrite this as log base 3 of 5 plus, and then since we are multiplying the 5 and the x, I can split this up into a completely separate log base 3 of x. And this goes back to our multiplication of exponents rule. So for example, if I have 3 to the power of 5, and I'm multiplying that by 3 to the power of x, what ends up happening is that I add my exponents together, 3 to the power of 5 plus x. Essentially, that is what we are going to be looking at when we are using our product to sum rule. To expand logs, this is exactly what we are going to be doing. We are going to be looking for all of the possible ways that we can split our log up into as many logs as possible. So right now, the only rule that we have is if there's multiplication inside your log, then we can split it up. So I'm going to be looking for multiplication. I see 30 times x, so there is one set of multiplication right here with this 30. Times, and then I see another x times 3x plus 4. So I see 3 pieces or 3 factors inside my log. So I'm going to go ahead and just work with one of those pieces for now. So log base 3 of 30x is being multiplied by 3x plus 4. So I can expand that by adding a whole nother log base 3 of that factor, which is 3x plus 4. Now in this log base 3 of 3x plus 4, I do have multiplication, but that 3 is only multiplied by the x. It's not a factor. It's not also being multiplied by the 4. So unfortunately, I cannot split up this log any further. I do not have a common factor between the 3x and the 4 that I can factor out. But here I do have a 30 times x, and there is only multiplication between the 30 and the x. So I can split this up now into two logs, log base 3 of 30 plus, and then I have another log base 3 of x. So this gave me my log base 3 of 30x, and then I still have the log base 3 of 3x plus 4. And this would be as far as I can expand my logs. Example 753, we are expanding log base 6. So the only rule that we have to work with right now is that multiplication becomes the sum between two logs. But I don't see any common factors here. I do see lots of multiplication, but again, no common factors. So I'm going to go ahead and factor this out. So log base 6, and then when I factor 3x squared plus 25x plus 28, my first factor is 3x plus 4, and then I have an x plus 7. And now that I've broken this down into factors, I can use that product rule for logarithms. So I've got 3x plus 4 times x plus 7. So the first factor I can write as its own log, log base 6 of 3x plus 4. And my second factor, x plus 7, I write as its own log, log base 6 of x plus 7. And then I add those two logs together, which takes the place of the multiplication of those factors. All right, go ahead and pause the video and try these couple on your own. To expand, I see just a times b, so there are two factors, which means I can split this up into two terms, log base 4 of a and log base 4 of b. Here I can split this up into three terms because I see three factors that are all being multiplied, log base 3 of 11 plus log base 3 of 5 plus log base 3 of x. To condense, I make sure that we have the same base, and the addition in the middle just means that we can put this back into multiplication. So log base 2 of, and then I multiply my x and my y as the two factors inside my log. So all we did is we reversed the process that we used in numbers 1 and 2. Question 4, I've got log base 9, base 9, base 9, and we are adding in between the three of those logs, which means that I can keep my log base 9 and simply multiply 5 times a times b as three factors within my log. So we again took that process that we used in number 2 and just reversed it and went back to where we started. Quotient rule is very similar, except that with division, we are going to be subtracting. This is going to be because our division does result from multiplication with a negative exponent. I'm not going to get into that quite now, but this is very, very similar to our multiplication rule, our product rule for logarithms. But now our quotient rule says if we are dividing, then we subtract. Your numerator will be your first, and then we subtract our denominator. So in example 754, I'm going to go ahead and expand as far as I can my logarithm. So the first thing I'm going to focus on is the fact that I see a quotient. So I'm going to go ahead and split this up as numerator minus denominator. So I keep my log base 2, and my numerator is 15x times x minus 1. So that is my entire numerator. And then I subtract a whole new log base 2 of my denominator, which is 3x plus 4, multiplied by 2 minus x. Now I can continue expanding because I do see that I can apply my product rule. I see multiplication inside this first log, which allows me to split this up as log base 2 of 15. Another factor that I see is x, so plus log base 2 of x. And then I see a third factor of x minus 1, so plus log base 2 of x minus 1. So I took this log base 2 and took the three factors and rewrote three logs, one for each of those factors. Now I'm going to be subtracting this whole second log. So I'm going to go ahead and use some brackets. And I'm going to work on this log here. I do see two factors inside that log, so I'm going to split this up as log base 2 of my first factor, which is 3x plus 4. And then since I'm multiplying, I have plus log base 2 of 2 minus x. Keep in mind that I did keep this in brackets because we are subtracting the entire log base 2, which I split up into 2 logs, but all of this is still log base 2 from the original statement, so I need to make sure I'm subtracting all of it. So now my last step to simplifying is to just distribute that negative to both of my logs. So I then have log base 2 of 15 plus log base 2 of x plus log base 2 of x minus 1 minus log base 2 of 3x plus 4 minus log base 2 of 2 minus x. And this, so far, would be as far as we can expand our log. Example 755 says contract the logarithmic expression, or in other words, we are going to condense it, and then we'll simplify where possible. So ln is just a special case. ln is the specific case where I have log base of e. So really this is log base e of 6 times x to the power of 9. So all of our same rules still apply. Subtraction means that we are going to condense this into a division question with my numerator and my denominator being first and second respectively. So I condense this down into a single log, natural log of my numerator is 6x to the 9th and my denominator is 3x squared. And then I can simplify by reducing my fraction, and I have 2x to the 7th power. All right, your turn. Go ahead and pause the video and try out these 4 on your own. Number 1, I should have log base 7 of 3 plus log base 7 of x plus 5 plus log base 7 of x minus 7 minus log base 7 of y minus log base 7 of y minus 2. And that would all go with number 1. Number 2, I'm going to go ahead and go below and I'll do number 2 in red. We should have log base 6 of 4 plus log base 6 of b plus log base 6 of 2a minus 5 minus log base 6 of b minus 6 minus log base 6 of 3 minus 2a. And to condense, I'm going to go ahead and go from left to right. So I'll start with the first 2 logs, numerator minus denominator, so this would be a over b plus 2. And then I'm adding on log of a minus 1, which means I'm going to multiply. So multiplying these 2 together, I've got a times a minus 1 in my numerator over b plus 2 in my denominator. And number 4 will be very similar. I'm going to work from left to right. So I've got log base 6, and then I'm going to multiply those 2 together to get 5 minus x times y plus 2. And then we are subtracting, which means that this x plus 4 is going to be a denominator. So condensing all the way, I've got 5 minus x times y plus 2, and then I'm subtracting another log base 6, which means I divide this by x plus 4, and that is as far as we can go to condense my log. Okay, we have a power rule. A power rule simply says that if the inside of your log has an exponent, we can move that exponent out to the front. So here I have x to the 5th inside my log, so I'm just going to scoot that out to the front, and I get 5 times log base 2 of x. It works in reverse to condense or contract. I can put that 4 back on, so this is going to be natural log of x to the power of 4. Okay, go ahead and take a moment to pause and try these few on your own. There are a few ways to start. I'm going to go ahead and start with that exponent of 2, giving me 2 squared over 3 squared. Then I'm going to split this up using my quotient rule, so 2 squared minus log base 7 of 3 to the 4th power. And then I move my 2 to the front because it is an exponent, log base 2 of 2 minus, move my 4 to the front to get 4 log base 7 of 3. And I'll go ahead and quickly show you the answers for the remaining 3, so you can check your work there. Now I do have a few Now I do have a couple more advanced questions for you to practice, so go ahead and pause the video and try these on your own. Hit play when you're ready to check your answers, and other than that, that brings us to the end of our video. Thanks for watching.